Imagine asking ChatGPT to analyze your company reports, search your knowledge base, book a meeting, send an email, update Salesforce, generate code, and verify that everything it says is accurate. How does it actually do all of that? Most people think AI is just one giant language model, but that's like saying a smartphone is just a touchscreen. The truth is far more interesting. Modern AI isn't one technology, it's an entire factory. Every request travels through multiple specialized layers. One layer understands language, another retrieves information, another remembers knowledge, another controls tools, another enforces security, another measures quality. Together, these layers create the intelligent AI applications we use every day. Today, we're going to walk through the complete AI factory stack, from the moment you ask a question until AI delivers its final answer. By the end of this video, you'll understand how companies like OpenAI, Anthropic, Google, Microsoft, and countless startups build production-grade AI systems. Let's begin. The big picture. Imagine hiring a brand new employee. They're incredibly intelligent. They can write, explain concepts, summarize books, write software, translate languages, solve math. But they have one problem. They know nothing about your company. They don't know your documents. They don't know your customers. They can't access your CRM. They can't send emails. They can't browse your databases. They don't know your business rules. That employee is the large language model. The LLM is brilliant, but isolated. Everything else in the AI stack exists to give that intelligence memory, context, tools, security, and accountability. Think of the stack like building a human worker. The brain thinks. The library provides information. The memory stores knowledge. The hands perform work. The phone connects to others. The security guard prevents mistakes. The manager checks quality. Without all 7 pieces, AI remains just a chatbot. With all 7, AI becomes an enterprise employee. LLM, the brain. Every AI system starts with the LLM. Large language models are prediction engines trained on enormous amounts of text. Their job is surprisingly simple. Predict the next most likely token. Yet, from that simple objective emerges reasoning, writing, coding, translation, planning, and conversation. Think of the LLM as the brain. It understands language, recognizes patterns, generates responses, explains concepts, writes software, creates images or code when paired with the right models. Today's leading models include GPT 5.5, Claude, Gemini, DeepSeek, GLM, QN, Grok, and Llama. But here's something many people misunderstand. The LLM doesn't automatically know today's news. It doesn't know your private files. It doesn't know your company's documents. It only knows what it was trained on, or what you provide during the conversation. That's why modern AI systems almost never rely on the LLM alone. Instead, they first retrieve the right information. RAG, the researcher. Suppose you ask, what is our company's vacation policy? The LLM doesn't know. Instead of guessing, the system performs Retrieval-Augmented Generation, or RAG. RAG works like an incredibly fast research assistant. Before the AI answers, it searches trusted knowledge sources such as PDFs, company wikis, SharePoint, Confluence, Notion, Google Drive, databases, or internal documentation. It finds the most relevant information. Only then does it pass those documents to the LLM. The LLM now answers using real company data instead of memory. This dramatically reduces hallucinations. Instead of making something up, the AI cites actual documents. Imagine asking, what changed in our security policy last month? Without RAG, the AI guesses. With RAG, the AI finds last month's updated policy and answers accurately. This is why enterprise AI systems almost always use RAG, vector database, the memory. But how does RAG search millions of documents instantly? That's where vector databases come in. Traditional databases search words. Vector databases search meaning. Here's an example. Imagine searching for, how do I reset my password? The document says, account credential recovery. A keyword search might miss it. A vector database understands they mean the same thing. Here's how. Every document is converted into mathematical representations called embeddings. Embeddings capture semantic meaning rather than exact words. Documents with similar meanings end up close together in high-dimensional vector space. When you ask a question, your query is also converted into an embedding. The vector database finds the closest matches based on meaning, not keywords. Meaning. Popular vector databases include Pinecone, Weaviate, Qdrant, Milvus, Chroma, pgvector, and VIS. Without vector search, enterprise AI would struggle to retrieve relevant information quickly and accurately. AI agents. The doers. So far, the AI can answer questions. But what if you ask, book a meeting with Sarah, summarize yesterday's sales report, email the summary to my manager, and create a Jira ticket? Now the AI needs to perform actions. This is where AI agents come in. An AI agent is more than a chatbot. It's a decision maker. It can plan, reason through multiple steps, choose tools, execute workflows, observe results, recover from errors, and continue until the task is complete. Instead of one prompt and one answer, agents operate in loops. Think, act, observe. Think again. Imagine telling an assistant, research competitors, build a PowerPoint, create charts, email the presentation, schedule tomorrow's meeting. That involves dozens of actions. The AI agent coordinates everything. Frameworks such as LangGraph, Crew AI, AutoGen, OpenAI's Agents SDK, Anthropic's Agent Patterns, and similar orchestration frameworks help developers build these systems. Agents are becoming the operating system for AI-powered businesses. MCP, the Universal Connector. An AI agent is only useful if it can access external tools. That's where the Model Context Protocol, or MCP, comes in. Think of MCP like USB-C for AI. Instead of creating custom integrations for every application, MCP defines a common protocol that allows AI assistants to discover and use external tools in a standardized way. An MCP server can expose capabilities such as reading files, querying databases, searching GitHub, managing cloud resources, accessing Slack, using Google Drive, running SQL queries, interacting with APIs. Rather than learning every API individually, AI systems that support MCP can connect through a common interface. It's important to remember that MCP is an emerging open standard, not the only integration approach. Many production systems still rely on direct APIs, built-in function calling, open API specifications, or custom enterprise connectors. MCP aims to make those integrations more portable and consistent. As adoption grows, developers may spend less time building one-off integrations and more time building intelligent workflows. Guardrails. The safety layer. Giving AI access to tools creates new risks. Imagine an AI accidentally emailing confidential information, deleting customer records, violating company policy, generating harmful advice, or leaking sensitive data. This is why production AI systems include guardrails. Guardrails enforce rules before, during, and after the model generates a response. Examples include checking user permissions, removing sensitive information, blocking prompt injection attacks, preventing data leakage, enforcing company policies, filtering unsafe outputs, complying with regulations. Think of guardrails as security officers watching every AI decision. Without them, enterprise AI would be far too risky. Evals, measuring intelligence. Finally, how do companies know whether their AI system is actually improving? They use evals. Evaluation is one of the most overlooked parts of AI engineering. It's not enough for the AI to sound smart. It has to be correct, reliable, fast, safe, affordable, useful. Engineers continuously measure accuracy, hallucination rate, retrieval quality, latency, token usage, cost, safety, tool success rate, user satisfaction, regression tests. Every time the AI system changes, these evaluations run again, just like automated software testing. Without evaluation, companies have no reliable way to know whether an update made the AI better or worse. Putting everything together. Let's follow a real request through the entire AI factory stack. You ask, summarize yesterday's sales, compare them with last month, create a presentation, email it to my manager, and schedule a meeting. Here's what happens. Step 1. The LLM understands your request. Step 2. RAG searches your company's reports. Step 3. The vector database finds the most relevant documents using semantic search. Step 4. The AI agent creates a multi-step execution plan. Step 5. It uses MCP or other supported integrations to access your email, calendar, presentation software, and internal systems. Step 6. Guardrails verify permissions, protect sensitive information, and enforce business policies. Step 7. Evals monitor whether the workflow succeeded, how long it took, how much it cost, and whether the output met quality standards. Only after all these layers work together do you receive the polished result. That's why modern AI applications feel so much more capable than a standalone chatbot. The biggest revolution in AI isn't just building larger language models, it's building complete AI systems. The LLM provides intelligence. RAG provides knowledge. Vector databases provide memory. Agents provide action. MCP and other integration methods connect AI to the outside world. Guardrails provide safety. Evals provide continuous improvement. Together, they transform a language model into a reliable, production-grade AI platform. As AI continues to evolve, understanding this architecture will become increasingly important, not just for AI engineers, but for developers, architects, business leaders, and anyone building AI-powered products. If you enjoyed this deep dive, subscribe for more videos where we break down complex AI concepts into clear, practical explanations you can apply in the real world.